Hey everyone, my name is Venerin, and in this video we're going to have a look at SDXL Turbo, a model that you can use to generate images from text. How good it is? Let's find out. This is the official announcement blog post for the SDXL Turbo model that is based on the SDXL model by Stability AI, and this one is actually quite a lot faster compared to the original one, and they're saying that they're using this new distillation technology or technique that is enabling one-step inference or image generation, which is something that the previously models had to do maybe 30, 40 or 50 steps in order to produce similar results, at least according to the authors. So the weights for this model are actually available on the Hugging Face repository, but the model itself is not intended for commercial use. So please be advised if you plan to integrate this model into your pipelines. And the new technique that the guys from Stability AI are using, the distillation technique, is called adversarial diffusion distillation, or ADD. And if you want to have a look at deeper dives on what diffusers are and how they work, please let me know down in the comments below. We might actually start a course, or let's say a couple of videos on which we can go through what diffusers are and how do they work. Of course, those models are very interesting, and the state-of-the-art results are coming out, or models are coming up pretty much every week or month. So they're also discussing the advantages of adversarial diffusion distillation, and they say that this is something that is similar to what you can get from GANs or generative adversarial networks. And one of the most useful benefit of that is single step image outputs. So you can do just a single pass over the image, and this is the actual result that you might get as a best result. So here they're comparing the SDXL Turbo model to other diffusion models. And you can see the comparison on image quality. On the left, you have the SDXL Turbo with a single step, and then other models, including the SDXL Turbo with 4 steps. So even though the authors are claiming that the one-step responses are very good, you can see quite clearly here that the image quality is much better when you're using 4 steps instead of 1, but still this is, at least according to this performance benchmark, is better compared to SDXL 1. So this is a great achievement if that's true. And here you can have a look again at the SDXL Turbo with 4 steps compared to pretty much the same models. And you can see that the 4-step inference time, or the 4 steps for the inference, are actually beating pretty much everything, at least on this benchmark. And these are the alignments that you can get from the prompt that you're passing in. So you can see that actually the model is performing very well, at least compared to all of these models. This is the official demo of the SDXL Turbo model. Let's see what it can do. Yeah, as you can see, this model is quite fast. Let's have a look at it a bit further in a Google Colab notebook. I have a Google Colab notebook that is already running, and you can see that I've installed all of the required dependencies here. We have the diffusers models, we have the transformers library, then the accelerate library in order to load this model. And you can see that I'm actually using the free T4 GPU that is available from the Google Colab instances. And you can see that I've already loaded the model, which is from the Hugging Face repository. I've loaded the floating point 16 variant. And yeah, this is essentially the type that I'm passing in as well. And I just put the model to the GPU. So you can see that the model is taking roughly 7 gigabytes of VRAM. So that's not that much. And if I close this and go to our first prompt, I've also loaded this font that we're going to use. So here is the prompt. It's quite long, but I want to show you the response to that. Let me just run through this and we'll see how much time does it take for this image to be generated. And you can see that it took roughly 3 seconds in order to generate this. This is the prompt. You can read it on your own or go and visit the Google Colab notebook that I'm going to share down into the description of this video. And you can see that pretty much the way that we've loaded the model is very similar to what we have from any of the transformers library. The interface is pretty much the same. And then the image generator, to it we are passing in the prompt that we are actually writing right here. And then I'm going to pass in the number of inference steps. Then this parameter, which is going to be the guidance scale, which we are going to mostly keep to a 0, at least throughout this tutorial. And then the generator is going to make sure that I'm seeding this generation, so I can essentially repeat the experiments that you're seeing on this video. So let's see what we have as an output. And you can see that we have these images from this dictionary like object, and then we are generating just a single image. To show you what an image looks like, this is actually a PU image. So this is the first generation that we had. So this is the llama in a bottle watching at the sunrise. So this is pretty amazing from this model thus far. And I'm going to explore this parameter number of inference steps a bit. I'm going to try out essentially numbers from 1 to 6. And if you recall, we got to look at the paper or the blog post original version where they said that actually 4 was pretty much the best possible result. We are going to check it out at least on this prompt. The prompt is the same as the previous one. And yeah, I'm going to also set the generator to the same number in each iteration. I'm going to skip through this function. This is essentially creating a way to draw essentially a grid of PU images. All right, so I'm going to call this function. We've already created the inference, and the inference, as you can see, roughly took, it took pretty much 6 times the first inference. So the number of steps that you're adding in are pretty much linearly going to increase the time which you're going to wait for a generation. And this is the actual results of the steps. So this is exactly the first step. The second step, inference. Third step, you can see we have an extra llama right here, which is quite strange, but I really love the detail right here. The first one was also amazing. So this far, actually, this is by far the best, but this looks a bit more detailed. I'm not sure if this is an extra leg or not. Yeah, it's a bit hard to tell. So 4 steps. This also looks pretty amazing, actually. Then 5 steps and 6 steps. This doesn't look so realistic anymore. And I think the llama is actually somewhat deformed with apparently, yeah, here and here we have some extra legs, which is a very common thing with this model. At least I think so, or I found this far. Yeah, I really love the 4 steps, but I also like the simplicity in the first or one-step approach. So for the next parameter that I'm going to show the difference here, and I'm setting the number of inference steps to 2, we are going to essentially play with the guidance scale parameter. I'm going to do exactly the same thing, but this time I'm going to change the guidance scale, and I'm going to stay with numbers from 0 to 5. And this is pretty much the response. Personally, I don't think that there is any difference between these two. Let me know down in the comments if you find any. But you can see that once we reach scale or guidance scale 2, you can see that there is some drafty or artifacts within this image. And if you go further down the scale, you can see that the image is completely distorted. So I would not use throughout this tutorial anything larger than 0 actually. But yeah, let me know if you are finding this parameter useful, since I'm not getting any essentially better feedback from playing around with this parameter, at least with the SDXL Turbo model. So next I'm going to create this helper function, which is going to take just the prompt, the number of inference steps, the guidance scale, which is going to be set to 0 by default, and then a seed parameter, so we can essentially replicate the results for you. And the first part, or the first group that I like to explore with these diffuser models is how good are they at producing animals. And here we are going to have a look at the tiger produced by this model. Yeah, as you can see, this actually looks very realistic. The patterns of the tiger on his head or her head, but I still think that this is a male tiger. Yeah, you can see the level of detail. Maybe the eyes are not exactly perfect, but still it looks rather amazing. And all of this was generated for roughly 1 second with 4 inference steps. Let me show you what happens if you get like 1 inference step. Yeah, you can see that the tiger actually looks good, but the eye, not so sure about it, but still very good look in under a second. Let's try 2. Again, probably some issues with the eye. And let's expand this a bit further. Let's say 10. And let's have a look at the result. Yeah, you can see that it is getting a bit more cartoony, I would say. Let's try 16, just to go to the extreme. Yeah, much more cartoony like. And I really like, for example, 5 or 4. Yeah, you can see the start of this cartoony style, and if you lower this a bit further, you get this much more realistic image, at least with this prompt. And these actually detailed instructions for the texture and the background, they do really help, and I'm going to explore this in a bit more. So this is again an upgrade to the styling of this image. You see this fox that this model is producing. Yeah, I would say that this is looking like an art, and I really love the response from this. Again, if we try to change the number of inference steps, you see that either way, the response is pretty good. And this charcoal drawing art, it appears to be working very well, at least with this model. Yeah, I really love the results for this particular prompt. So now that we've looked at some wildlife animals, let's have a look at some nature landscapes. And I'm going to start with a waterfall. So you can see that this is, let's say, a more cartoony style, or more, yeah, this should be reminiscent of Claude Monet, but I wouldn't say that the model is capturing the essence of it, but still, I love this response. I mean, it's very good for a generation of under 1 second as well. Yeah, this is looking quite amazing actually. The cascading waterfall with the pretty much everything, probably a bit more blue in the water, but still it looks quite alright. It's a jingle after all. And let's have a look at another landscape. So this one was a bit interesting, and I wanted this to display a hammock within some palm trees. But as you can see, something has happened with this palm tree. And yeah, if I actually reduce the number of inference steps, you see that the palm tree is actually still being cut off. So not sure what is happening here, but this doesn't appear to be drawing essentially the whole tree of the hammock. Other than that, the image looks pretty fantastic, I would say. The level of detail is quite good, and I just wanted fluid color transitions, and I love how the model is actually transitioning within the hammock covers right here with the white and blue, and you can still see the boundaries of the hammock, even though it's attached to essentially the air, and there is even a shadow of it. Yeah, I would say this looks pretty cool, except of course the hanging tree. So let's have a bit more of a look of the fantasy art style, sorry. And this is a dramatic scene on top of a medieval castle tower. So you can see that I've wanted to have an actual battle between a dragon and a knight. But in this case, the model is deciding that it doesn't want to essentially pin the one versus the other. And I've tried with different inference steps. Yeah, you can see the responses are not quite as what I wanted within the prompt. And there is this random sword happening here. So this is one of the responses that I was all right with. But keep in mind that you essentially need to play around with those parameters for each image. And then this is one that I really liked. So this one looks to me at least very well compositioned. The background is pretty much spot on based on the description that I've given it right here. I've put it in exactly the same prompt to DALL-E 3, and as you can see, this is pretty much stunning result compared to what we got from the SDXL Turbo model. But at least we are seeing that the SDXL Turbo model is actually performing a nice composition. Next, we're going to have a look at some people generation. And the first one is actually a depiction of Michael G. Scott from the TV show The Office inside his car. And I've tried to essentially add some tags for generating a much better human, because those types of models have pretty much a lot of problems if you're not essentially telling exactly what you want. And these tags, essentially with the cameras and the formatting and the color balance, etc., the white, they do really help. So try them out on your own. And let's have a look at the response. So this should be Michael G. Scott. Of course, this doesn't look anything like him, but I would say that the person looks very realistic. Yeah, the image looks quite all right. Let's have a look at another one. This one is of a woman. And yeah, you can see that this is actually clipping the number of tokens. So this is important to have a look at, since this is actually the limit of tokens, 77 tokens. And this is pretty much cutting off everything of here. So yeah, keep that in mind when you're writing your own prompts. But this is the response that we're getting. And you can see that this is hugely realistic image of a woman. Of course, most of those tags are actually doing the work here, because I remove pretty much that. Let me just have a look at these. And let's do a comparison between most of those tags. Yeah, you can see that in this case, the female is looking very good, but the level of whitening and essentially the realism of the white and the focus on her face along with the detail of her skin and all of those wines right here provided by these tags, and of course the hair. You can see that this is looking more like a doll, which is a problem that most of those models are having. But this looks much more realistic with a realistic whitening, and yeah, the smile and all of the detail on her skin compared to essentially the pretty much doll-like view of this image. So keep that in mind when you're playing with those types of models. These essentially tags are helping quite a lot in order to create these photorealistic images. All right. Let's have a look at some more examples. So this was, let's say, something again more futuristic of a warrior. And again, I've added some of the tags that we had thus far with dramatic lighting, cinematic, and post-production. And yeah, you can see that the level of detail is insane pretty much of this image. The armor, the helmet, essentially the whole structure of this warrior standing strong and tall on a backdrop of probably a battle that is currently happening or has already happened. And if we increase the number of inference steps for this one, you can see that the level of detail is again getting a bit more cartoony, even at 4. Yeah. So at 3, you can see a battle in the background with more detail on the sword. And here it looks like he's killing himself, not sure. Yeah, but at inference steps 3, it looks like pretty much great. And inference steps 2, again, very good detail. Yeah, actually, inference steps 3 looks a bit more detailed. Yeah, I really like this with the battle on the background. Let's have a look at another one. Here we're going to generate a watch with some level of detail. And you can see that this model is not very good at actually writing. So yeah, these, let's say, digits or characters are not perfect. But overall, the detail of this watch and the idea behind the wrist strap is very good. I've actually wanted to have a holographic display, but this doesn't do it, at least with this prompt. Let's try this. No, pretty much the same. Yeah. And one final aspect of these types of models are the negative prompts. And let's have a look at this one example. Essentially, you're passing in the negative prompt to the image generator that we've created. And you can see the response of this model. A young woman standing in a restaurant table or sitting in a restaurant. And if I essentially get rid of the negative prompt, you see the response, how it is changing. Let's just copy and paste it, just in case to make the better comparison. I'm going to essentially delete the negative prompt. And yeah, you can see at least for this model, and at least I can't see any difference at all. So the negative prompting for the SDXL Turbo doesn't appear to be doing anything. The SDXL Turbo model by Stability AI is simply amazing. It is performing its inference within a second or two on a T4 GPU, and the results are pretty much very good compared to what we had from, for example, 6 months ago with such an open source models from the diffusers library. And pretty much you can play around with the prompts. Of course, you've seen that tagging and adding a bit more detail to your prompts is actually helping the outputs considerably. So let me know down in the comments if you've improved on the prompts, and I'm going to link the notebook within the description of this video. Thanks for watching, guys. Please like, share, and subscribe. Also, join the Discord channel that I'm going to link down into the description below. And if you want to have a look a bit more on what are diffusers and how are they trained, please let me know in the comments below so we can start a series on them. They look pretty amazing and we can get a bit of deeper dive within those models. Thanks for watching. Bye.